Here we go, 9.5, our last lesson of the school year, and we've saved the best for last. I think it'll probably be unanimous by the time we finish this lesson and you enjoy all that there is to offer here. Okay, go ahead and do the warm-up. So 2 problems, remember follow order of operations, remember PEMDAS or GEMDAS. Be careful with that. Pause the video, go ahead and try them. Okay, so I'm back and hopefully you did the 4 plus 4 and then you multiplied the 15 times the 8 and then multiplication before subtraction, so negative 3 times 120 and then got negative 361. On this one you'd want to go to the innermost grouping symbol first, so 5 plus 3, and then you'd want to do the 13 minus 8. We'd then do the exponent. So 2 cubed is 8, so we have a negative 8 there. And then here you would want to do the multiplication, 97 times 1, and then 97 times 5, and then combine those. Okay, the learning target. I will be able to use the quadratic formula to solve quadratic equations. This is a huge moment in your mathematics career. You will see references in movies, TV shows to the quadratic formula. And it looks like it's something that's super complicated and so forth, but it really isn't. And I promise you that by the time you finish this lesson, if you watch all the videos and do all the problems, you will have this thing down cold. Okay, so the quadratic formula. The real solutions of the quadratic equation, ax squared plus bx plus c equals 0, so notice standard form, are x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Notice a can never be 0. Think of it here. If a was 0, would it be a quadratic equation? No, it would be a linear equation. And also, if you look at the formula, if a was 0, we'd have a denominator of 0, and we know we can't do that with division. And then b squared minus 4ac, which is a special name that we'll come across later, that's got to be greater than or equal to 0. Think about why. If it's negative, will we get any solution? No. Okay, so we're going to derive it. That means kind of prove it. I don't want you to just take it, oh, Mr. Kalin says this is what it is. I want you to understand why. And now that you've learned completing the square, we're actually going to derive it this way. So let's go ahead and watch this video. So I think you can click on that button and that'll take you to it, or copy and paste the link. But go ahead and do it. And we will have this as an extra credit problem on the test. So I'm telling you right now what one of the extra credit problems is that if you can kind of derive the quadratic formula using completing the square, you will get extra credit. How about that? How nice. So go watch that video. So how cool is that? You guys actually can do that. You've learned how to complete the square. Man, that's amazing. Okay. All right, now let's watch some videos to help you get this in your head forever. So here's a quick one to the tune of Pop Goes the Weasel. So go ahead and go watch that one. Maybe even watch it twice. Go for it. All right, back. And now, I know some of you might be saying, oh, but man, this is still hard. Well, this one I would like the title or motto for it would be, if she can do it, then so can I. So go ahead and go watch this one. Cool, isn't that cute? I love the little sister there too. All right, and now it's time for the all-time classic. You probably heard rumblings from the class above you last year when they watched this. I really want you to focus in on the lyrics here. They're really amazing and ingenious. And they use a lot of the math terms we want. So really enjoy this. It's probably one of the most classic math music videos that's out there. I mean, it's just check out how many times it's been viewed. It's pretty amazing. So go enjoy. All right, so we're back, and that's it. I mean, for a quadratic formula, you just got to put it in standard form, figure out what a, b, and c are. It's just the coefficients, and c's the constant here, and then plug it in and simplify. Okay, so Is this in standard form? Yes. What's A? 2. What's B? Careful. -5. What's C? 3. Yeah. So plug them in. So negative and then -5, because B is -5, plus or minus the square root of, notice how I put the -5 in parentheses here? Think that's a place where people make careless mistakes? Oh yeah, you betcha. Okay, and then -4 times A times C. Okay, all over 2 times 2. So again, you'd want to make sure you're very careful to square this and then multiply all those together. And then you can combine. Okay, so when you do that, you should have gotten -520 squared is 25. -4 times 2 times 3 is -24. And then 2 times 2 is 4. Okay, well, we still have work to do inside that radical there, right? That's like a grouping symbol. 25 minus 24 is 1. So what's the square root of 1? 1. So we have 5 plus or minus 1 over 4. And yes, you get to play America's favorite math game again. How awesome is that? So there you have it. Now I want you to notice something. By the way, could we check these? Of course we could. We could plug in and check them. We can go ahead and do that. If I plug in a 1, 1 squared is 1 times 2, so I get 2 there. -5 times 1 is -5, and then plus 3, so I have 2 minus 5 plus 3. Does that equal 0? Yeah. And if you plug the 3 halves in, 3 halves squared is 9/4. 2 times 9/4 is 9 halves. -5 times 3 halves is -15 halves, and then this would be plus 6 halves. What do those 3 terms add up to? You betcha, 0, 0. Check, check. All right. But could we have done this a faster way? I mean, this was a lot of work to do this. Notice the answers here. They're rational, right? They're not like we didn't have a square root of 3 in our answer or something like that. That meant we could have done this by factoring. Obviously, we could always do it by graphing or completing the square, but those really wouldn't be faster. But we could have done this by factoring. And the idea is that you get quick with these and be able to use the most appropriate method to do it efficiently and accurately. Okay. All right. So I think at this point, why don't you go ahead and start trying these. So pause the video, try this one on the left. Okay, I'm back. So it is in standard form. A in this case is 1, B is -6, C is 5. Hopefully plugged in. Got to be careful with working inside there, right? So hopefully you got 36 minus 20. Still can simplify there. We get 16. Oh, and that's a nice one. Square root of 16 is what? 4. Play the cover-up game, and you get 1 and 5. Awesome. And again, go ahead and plug them in and check them, and you'll see that it works. Okay, try this next one. So pause the video, go for it. All right, I'm back. So A, you can put 1/2 at 0.5, whatever floats your boat, and plug in to -b plus or minus the square root b squared minus 4ac all over 2a. And love this section. Get that. And this one, isn't this interesting? We can't really do anything with the square root of 21, right? That's in simple rad form. And notice the instruction just said solve the equations using the quadratic formula. Did it say anything about rounding or giving an approximate solution or anything like that? No. So if it says that, we want the exact answer. And this is the exact answer, even though we don't know exactly what the square root of 21 is. We can approximate it out to a bunch of decimal places, but that's not the exact number. This is exact, okay? You might be saying, well, can I still check this? Yes, you certainly can. If you actually plugged in, like -1 plus root 21 and squared that binomial and then distributed 1/2 and then added that, it would all end up canceling out, being equal to 0, okay? Or you could take your calculator and get a good approximation of the square root of 21, add -1 to that, and then use that and plug that in for x. And it should also come out as well. All right, so here's some more. Notice the instructions here, though. Round your solutions to the nearest tenth. So if you do get the square root of a non-perfect square, you're going to want to kind of use your calculator to get an approximation of that and round to the nearest 10. Okay, go for it. All right, so back. And again, it was already in standard form, so good to go here. Hopefully you got A, B, and C were negative 3, 2, and 7. And then you plugged in. Really be careful in here with this, right? Notice we do have two negatives, so we know it's going to come out as a positive there. Okay, and you can see when we combine the 4 and the 84, we get 88, which is not a perfect square number. So you might want to kind of keep working with that. Remember 2 root 11, because root 88 is the same thing as root 4, root 11. I'm sorry, root 8, root 11. Ooh, wait a minute. That is not right, is it? There is a mistake there. Do you see that? What should root 88 become? Yeah, it should become what? It's root 4, root 22, isn't it? Okay, so yeah, that's not good. So this should not be 2 root 11 up there. What should it be instead? Yeah, 2 root 22. And then you can go ahead and simplify from there. So we'll go ahead and not put that one down. What would that be? Yeah, that would be negative 2 plus 2 root 22. So you still would have the same outies there. So you could reduce those. So you'd have root 22 in there instead of 3. And then you would take that and you would not get this. That is not correct. We would have had, what's the square root of 22 is what? Just a little under 5, right? So we would have 5 plus 3, which is about, 1 plus 5, which is about 6 divided by 3. That would be about 1.9. And 1 minus 5 would be negative 4. So maybe these actually probably are the correct answer. These should just be 22s instead. Sorry about that. Okay, hopefully you caught that mistake. All right, so on we go. What do you notice about this one? Hopefully you said it's not in standard form to start with. So go ahead and put it in standard form and then go from there. Okay, so hopefully you got A is 4, B is negative 4, C is 1. Plug into the quadratic formula. Have that. Again, be super careful. Minus a negative there. 1 negative, multiplying all that together. So we have 16 minus 16. Ooh. Ooh. We get 0 there. So how many solutions are we going to get here? Hopefully you said 1. Yep. Just 1, because plus or minus 0 is the same thing. Okay, good. All right, let's take a look at this word problem. The number y of northern Rocky Mountain wolf breeding pairs X years since 1990 can be modeled by the function y equals 0.20 x squared plus 1.8 x minus 3. Doesn't look like one that we probably want to deal with factoring, right? So this would probably be a good problem to use the quadratic formula for, since it's already pretty much almost set in standard form. We just have to, instead of having the y there, we're going to set that equal to 0. So when were there about 35 breeding pairs? So what are we going to do with that 35? Yeah, we're going to plug that in for y, right? Because y was the number of breeding pairs. So now what are we going to do? Put it in standard form. So what I did was I subtracted 35. Then it's in standard form. It's okay that it's over on the right side and the zero's on the left. If that bothers you, you can just kind of change the sides and then plug in. So go for it. So A is 0.2, B is 1.8, C is negative 38. Quadratic formula, the quadratic formula. Probably using a calculator for this. The quadratic formula. Quadratic formula, and it's negative b plus or minus the square root of b squared minus 4ac all over 2a, 2a, 2a. All right, and hopefully you got answers of negative 19 and 10. So what would the answer be here if it's X years since 1990. I hope you said 2000, because 2000 is 10 years from 1990. Can't use the negative 19, right? Not using that. Okay. All right. Now, these are some great videos, okay? I want you to watch this one. This is from Westerville High. Remind me in Westerville South High. Remind me to share a story with you in class about a time where I actually met some of the teachers from that school. So go ahead, enjoy this video. It's terrific. It's actually a great review of 4 methods for solving quadratic equations. The only one it doesn't necessarily cover all that much is the graphing method, but that's okay. All right, go enjoy it. All right, so you're back now, and I really want you to watch this one. You've heard me sing some tunes even in this lesson, but these teachers can really belt it out, and the tune should still sound familiar to you, so enjoy that one. It's got some great lyrics as well. All right. Okay, so second part of the lesson. If you're feeling like it, go ahead and click on that YouTube. Go back to the classic. Can never watch that enough times. We'll probably watch it in class again too, at least once. All right, but the lesson part here is, so I mentioned before that this b squared minus 4ac is a really important part of the quadratic formula. It's what we call the discriminant. And you've heard of the word like discriminate, like, oh, I've got a discriminating taste. So the reason we call it a discriminant is because it helps us know kind of, even before we've solved, how many solutions we'll have, okay? So in other words, another way of saying this, because the discriminant is under the radical sign, you can use the value of the discriminant to determine the number of real solutions of a quadratic equation. And remember, the number of real solutions of a quadratic equation is the same as the number of x-intercepts of the graph of that related function of that quadratic equation. So remember, x-intercepts of the graph, same thing as the number of real solutions. Okay, so what we're saying down here, interpreting the discriminant, meaning how can we use this information to kind of tell us how many solutions we're going to have. So if b squared minus 4a is a positive number, in other words, greater than 0, we're taking the square root of a positive number. How many real roots does the square root of a positive have when we take the square root of a positive, or the root of a positive? It has 2, right? So example would be, what if it was the square root of 10, right? We don't know exactly what that is, but we know it's a positive 3 point something, and it's also a negative 3 point that same something. What would the graph of that look like? It's going to look like one that has 2 x-intercepts, okay? 2 x-intercepts. And by the way, it could point down too, but it would still have 2 x-intercepts. Okay, well, what if b squared minus 4ac, our discriminant here, is equal to 0? Well, then we would be taking the square root of 0. And 0 only has 1 square root. So we would end up getting something plus or minus 0. And as we saw in the problem earlier in the lesson, plus or minus 0 is the same thing. So this would be a situation where the graph would have just 1 x-intercept. In other words, the vertex for the parabola, whether it opens up or whether it opens down, would be on the x-axis. Okay, and what if b squared minus 4ac is less than 0? In other words, it's a negative number. Can you take a square root of a negative? Absolutely not. So a graph might look like this, or it might be down here like this. No real solution to that because it doesn't have an x-intercept. Okay, so what I want you to do here is determine the number of real solutions of x squared plus 8x minus 3 equals 0. Okay, so really, not really asking you to solve this. We're just saying figure out what the discriminant is, and if it's positive, it's 2. If it's 0, it's 1. And if it's negative, it's 0. Or no solutions. So A is 1, B is 8, C is negative 3 because this was in standard form for us. So let's plug in. Notice I didn't even write out the full formula here. There's no need to, right? I'm just doing the b squared minus 4ac part. And what do I get here? I get 64 minus 4 times 1 times negative 3. Two negatives being multiplied makes it a positive 12. So that means it's going to be what? 76. So our discriminant is 76. That's a positive number. So 2 real solutions. Simple as that. Okay, try this next one. Notice something different about this one, though. It's not in standard form. So you had to put it in standard form. Go for it and try it. Okay, so hopefully A you got for 9. B was negative 6. C was, oh, whoops. Let's get that back. C was, there we go, 1. Again, just need to figure out the discriminant, the b squared minus 4ac. Hopefully you got 36 minus 36, which we know is 0. So how many real solutions would that mean we have? Just 1. Doesn't mean 0 is the solution. I hope you understand that, because remember, you would still have this negative b plus or minus the 0. So it would still get negative b over 2a. That would be what your answer is, what your solution is. Okay, let's go on. Go ahead and try this next one. All right, so hopefully you noticed it already was in standard form. Discriminant. Again, 16 minus 16, another situation where we end up getting 0. So there's 1 real solution. Nice. Okay, and try this next one. Hopefully you put it into standard form. What's A? 0.5 or 1/2. B is negative 7. Always take that sign. C is 1. Discriminant, negative b, b squared minus 4ac. So negative 7 quantity squared. And then that. And what do we end up getting? 47, which means there is 2 real solutions, because last time I checked, 47 is a positive number. Okay, now instructions change slightly. Find the number of x-intercepts of the graph of y equals 2x squared plus 3x plus 9. So yeah, you could go and graph this and figure out whether your parabola intercepts the x-axis in 2 places, 1 place, or not at all. But can we also just use the discriminant to find how many real solutions there are? And whatever number of real solutions is the same as the number of x-intercepts for the graph. So, exactly, put it in standard form. A, B, C. What's the discriminant going to be? 3 squared minus 4 times 2 times 9. And what do we get out of all that? Ooh, we get a negative. So how many x-intercepts? Hopefully you say 0, because why? Because there's no real solutions. And again, the number of solutions, real solutions that you're going to have is going to be the same as the number of x-intercepts. So no real solutions, 0 real solutions means 0 x-intercepts. Okay, try the next one. All right, hopefully you set it equal to 0. A, B, C. And again, I hope you're seeing how tedious this can be in some situations to actually use. But it is nice if this is the only question, if we're asking how many x-intercepts there are, or just how many solutions there are. So negative 23, again, another negative. So no solution, no x-intercepts, 0 x-intercepts. Okay, fun, same thing here. So go for it. This one, again, set it equal to 0. A, B, C. Just need the discriminant. Don't have to use the whole formula. And so this gets us what? 1, and then, ooh, we got a 0 there. So this is all going to go to 0. So we end up getting a positive number of 1. So how many x-intercepts? 2, because there are 2 real solutions. Okay, try this one. Man, you guys are going to have this down. So set it equal to 0, A, B, C, discriminant, b squared minus 4 times 1 times 36. And we get 12 squared, 144, minus, wow, what a coincidence. 144 gets us 0. So how many real solutions are there? 1, right? Which means we're going to have 1 x-intercept. Okay. And this is a nice chart that shows you all 5 methods. So congratulations. At this point, you now have been exposed to all 5 methods for solving quadratic equations. Remember, we started with factoring and using the zero product property back in chapter 7. Graphing, again, may not give exact solutions, or it's hard to pick it out, you know exactly what it is, or impossible. Get a nice approximation on Desmos, maybe sometimes out to 3 decimal places, but we don't know exactly if that's what it is. We can use a graphing calculator with that, so there's advantages to it and also disadvantages, right? And with factoring, we saw it's straightforward, it's very efficient, easy to do, using the star method, the old-fashioned way, you know, looking for perfect square trinomials or difference of 2 squares. But sometimes we can't do that. Using square roots or extracting the root, very nice when you have things that are in this form, or like a binomial squared equal to a constant. But again, we can only do that in certain situations. Completing the square can involve difficult calculations. But if A is already starting out as 1, it's a great opportunity to use it, and especially if B, you know, and ax squared plus bx plus c is even. So we don't get kind of those fractions and so forth. And then the quadratic formula, right? Takes time to do the calculations, so not real efficient, but it can be used for any quadratic equation, and it will give you, you know, an exact solution, even if that might mean like 3 plus or minus the square root of 7 over 4. That is still considered exact. Okay, so which method would you use to solve these equations, and then why? All right, well, for A, probably want to use completing the square or the quadratic formula, because if you put it in standard form, it's not factorable, and B is even, so that means that the completing the square would probably be easier. But if it's not factorable, and obviously we can't use extracting the root, not a good idea to go with those. And generally, graphing probably is not going to be the best way, because that always takes a bit of time. Okay, what about this one? Go ahead, take a look at it. You kind of want to look and see, you know, can I factor it? Okay, yeah, it's already in standard form, so that's a nice start for factoring. And you can factor this. It's easily factorable. Okay, what about C? Okay, yep, already standard form. It's factorable. You know, x plus 6, x plus 2. Pretty simple to see that. Okay, try D. Pause the video, try D. Hopefully you said factoring, already in standard form, and we can factor that, right? What's that come out? That's x plus 12, x minus 1. Okay, what about this next one? Look carefully at it. Okay, I'd use extracting the root or using square roots, because you can quickly put this into the form of x squared equals d, right? If you added 5 to both sides and divided by 9, pretty simple to do. Okay, what about F? Try it. Probably want to use a quadratic formula. It's already in standard form. Hopefully you saw pretty quickly it's not factorable. And if we divided everything by 5, our b is going to become a fraction. It's going to become 0.2 or I'm sorry, negative 0.2 or negative 1/5. And that's just going to get wonky. Could it be done using completing the square? Of course, it could be, but probably not the best way. And then try this last one. Yeah, completing the square, because a is already 1 and b would be an even number, and that one is not factorable. You probably saw that pretty quickly. Okay, good. So now I want you to go ahead and write a quadratic equation that you would not solve using square roots. Okay, not. Okay, so Here's an example of one that I put in. Why would I not want to use square roots for this? Well, a couple reasons. One, it's easily factorable, x plus 3, x plus 2. So that would probably be faster. And even if I wanted to make this factor this, it wouldn't factor to a perfect square trinomial where then I could take the square root of both sides. Okay, so B. So now we're going to try and write one that's you wouldn't want to solve using factoring. Okay, try it. And then here's my example. And why would I not want to do this using factoring? Well, it's not factorable. There's no factor pairs that are going to work here. Okay, one for not completing the square. Okay, for mine, notice not only is my leading coefficient, my A, 5, so I'd have to divide everything by 5, but my B coefficient is an odd number, so that's kind of like the double whammy. Not going to want to complete the square there. Could you do it? Yes, you could, but probably not the best way to go. All right, and then here's an interesting wrap. If you want to watch a quadratic wrap, check it out. And then here's our Westerville South again to wrap it up. Can't watch that one and listen to that one enough times. All right, well, congratulations on making it through all the material for Algebra AB. It's a big moment for you. Learned the quadratic formula, got through all the material. Congratulations, and I'll see you in class.